Hello everyone, thank you for joining us for another Digital Dimensions webcast. My name is Cody Armstrong, and today we'll be going over mold making in SOLIDWORKS. So, SOLIDWORKS offers a lot of very specific mold making tools. Some of the tools that come into mind on the mold tools toolbar, parting line, parting surface, tooling split, core, shutoff surfaces. A lot of these tools are heavily automated specifically for mold makers to create the mold as quickly as possible. Okay, but there are some other commands that you may be used to that are not necessarily specific to mold makers, but are definitely very beneficial. The one that sticks out the most is definitely the combine command. The ability to subtract one body from another, the ability to do Boolean operations is definitely a big benefit. But there are others. If I'm doing in-context work in a part where I need to move bodies around, move copy is going to be the command I use. If I need to do any delete faces or to modify any imported geometry that I'm trying to create a mold from, a lot of the surfacing tools are going to be necessary. Delete face, move face, so on. Cavity is a big one because it's essentially a Boolean operation, but at the assembly level. I can subtract one component from multiple components that are separate parts. Okay, so that's definitely a very useful tool. But like I mentioned a moment ago, there's definitely a correlation between the mold tools that I'll be using and surfacing tools. And that's not to say that I can't create a surface model and it has nothing to do with the mold. It's just that a lot of the common mold making techniques involve surfaces. In fact, when I go over these automated tools in the mold tools toolbar, you'll notice there are a lot of very specific surfacing commands that are necessary in order for me to get my mold. Okay, one that comes to example at the top of my mind is just the parting surface. The parting surface defines where the core and cavity will be split from the model. Okay, so it's definitely a very useful tool, but there are other shutoff surfaces and just the common techniques when working with a lot of imported bodies as well. So like I mentioned, there's a mold tools toolbar, and now if you don't have it up, I'll show you how to get this toolbar onto your command manager in just a second. But these toolbars are very specific to mold makers, and that's the reason they're there. You'll see a lot of the specific commands for mold makers: shut off surfaces, parting surfaces, tooling split, like I mentioned earlier, but also a lot of the surfacing tools you'll see on the left hand side there as well. And like I mentioned, we're going to go over some of those later on. And then there's also an insert menu. There's an insert. If you go to insert, you'll see it molds drop down. Okay, and it lists a lot of these mold specific tools if you prefer to use the insert menu. And so what I'd like to get through today is, first off, I'd just like to cover a basic lesson of the usual tools. Okay, the regular automated tools that SOLIDWORKS provides for creating a mold quickly. The parting surface, parting line, tooling splits that I was mentioning earlier. But after that, I'd like to get into an example of creating a mold using what I call the regular tools, but using the not-so-automated tools that are provided by mold tools. Combine, doing a little more manual work to get the mold created. Okay, not impossible, not hard by any means, just a little more manual. And then lastly, I'd like to go over making a complete mold from scratch, and not just creating the mold, but also creating the actual assembly of the mold, the ejector plates, the different gate sprues, electrodes, cooling features that are involved in a mold itself. Okay, do a little bit of in-context work as well. So with that, let's go ahead and get into SOLIDWORKS. And the first thing I'd like to call up is a model of an iPad. Okay. Now before I get started on this, I have to thank Mike Puckett from SOLIDWORKS. He's the one that provided this model. It's actually on 3D Content Central. You can download as well. He participated in a rendering contest, built the model, and just for kicks submitted it for everyone, so you can get it as well. But what's so nice about this model is it's neatly organized into different bodies. Okay, I have some surface bodies, some solid bodies there. What's nice about this is I want to create a mold from this bottom piece. Well, it's one solid body. So if I isolate that body, you'll see the shell of the back piece of the iPad here. That's what I'm going to be creating my mold from. Okay. Now the first step for me though is to export this body into its own component so I can work on it separately. Okay. It's another very common technique for mold makers when you're working with multiple body parts. The ability to export one individual body and work on it separately as its own part is definitely beneficial. Okay, so I'm going to get out of the isolation here, but this is definitely the body we're going to be creating our mold from. Okay, so I'll exit the isolation, and I'm going to export this body as its own component. Okay, so if I right click here, you'll see the option Insert into New Part. Okay, when I click Insert into New Part, you'll see it brings up the Save As dialog. I give it a name, so I can say okay, hit Save. I'll just leave it the same name that it is, and now I have this body in its own component. Okay, now it's still referencing another component. You'll see that by the arrow there after the name. And if I go to List External References, you'll see the reference back to the original iPad. Okay, so there is still a reference tying if things will update if they change in the iPad design. But if I don't want that, I can break the references, or if I want to temporarily lock them just so I don't get an update, even though I may change the original, I can lock them here. But in my case, I'm not too concerned about that, so I'm going to go ahead and cancel out. And I'm going to get started with the mold making process. Now, the first step is to get all your mold tools up. You'll see I have a mold tools tab on my command manager. Okay. Now, if you don't see that, in fact, if I shut this one off and I shut surfaces off, you'll see I believe that's the default format. So if you just install SOLIDWORKS, you boot it up, I think that's what you're looking at. Okay. There are a lot of other tabs available that are specific to different types of modeling. You'll see surfacing, sheet metal, but the one I'm interested in is mold tools. Okay, I just click on mold tools. By the way, I just right clicked on one of the existing tabs to get this pop-up menu. And you'll see I turn on mold tools. It pops up in the command manager, and there are all my mold specific commands. Okay, so these are the commands I was referring to earlier, including all those surfacing tools I was talking about. Okay, now I can also go through the insert menu. Okay, you'll see insert molds and a lot of the mold specific commands. So let's go ahead and get started. Now the first step to using these mold tools is creating a parting line, and this parting line defines where you're going to separate the core and cavity. Okay, it's also used to define the parting surface, which is eventually used to define where I separate the core and cavity. So all this is kind of necessary in order to get the eventual tooling split that I'm shooting for. Notice it's grayed out right now. So to start this off, I'm going to go ahead and call up the parting line command. You'll see right here on the left hand side it says please use the draft analysis and select the direction of pull. Now the direction of pull is quite literally the direction this part will be exiting the mold. If you were to grab this part and pull it out of the mold, what direction would you be pulling? Okay, and that's probably the most literal explanation I can give of direction of pull. So if I select let's say this top face as my pull direction, you'll see an arrow pop up. Okay, now if I were to be pulling the mold out in that position, then that would be fine. Okay, but I'm not. I'm going to flip that direction around like so, and then I'm going to hit draft analysis. Okay, now you'll see I get a decent amount of draft. I could stand to draft these side faces, but I'm not too concerned about that now because I'm not actually making this mold. I just want to go through the steps. Now the next step is to define the continuous loop around the model that will define the parting line for this design. Okay, and it has to be a loop. You'll see there this message says select edges that form a closed loop. Now the quickest way to do this is not to go in here and highlight each individual line because it would take a while, and especially for more complex molds it'll take a long time. What I can do is right click, and you'll see two options here. Actually they would both work in this scenario. I can either select tangency or select loop. Okay. Now if I select tangency, it's going to select everything tangent to this line, which just so happens to be a closed loop, which works. Okay. So I select tangency, it creates a loop all the way around the iPad, and now I have a continuous loop to define my parting line. Okay. So you'll see here I get a lot of feedback. First off, all my edges are populated here, so if I need to edit or change anything, I could edit them here. But you'll notice I get a lot of feedback from this message dialog. Okay, the parting line is complete, but the mold cannot be separated into core or cavity. You may need to create shut-off surfaces. Okay, so this entire time it's looking to the inside of my parting line for any definable features that could cause a problem for the tooling split. Okay, and this message dialog is where you get all that feedback, and you'll see this in other commands as well. Okay, so no, I have my parting line done. I'm ready to move on, so go ahead and hit OK. And the next step for me is to create a parting surface. Okay, so I'm going to create a parting surface. It automatically picks up the parting line. Okay, because that was my last command. It sees it in the feature manager. It picks up the parting line. Then all I have to do is define the width of my parting surface. Okay, Now I'm going to explain the interlock surface, the option, when we get to the tooling split, but just to be safe, I want to extend this surface out, let's say, we'll go a little bit further, 50 millimeters. Okay. Now I want to take a second to explain this smoothing option. If I have a complex surface that isn't necessarily planar, but three-dimensional, there is a smoothing option which automatically adds radii. Okay. It adds radii so that you don't incur these huge expenses actually making this mold because you have dozens of sharp corners in your mold. Okay. This option right here will actually create a sharp corner effect in the mold where any surfaces may meet or where the transition may change. Okay, so if you want a simple radius instead of sharp corners in a lot of these designs, this is the option you want. And you notice it's on, by my case, in default. And then the distance is here. But this definitely helps a lot when it comes to creating the mold. Now, if you're not giving the level of detail you're looking for from the mold, you may need a sharp corner. Just keep in mind that EDM processes may be necessary, which obviously the cost is going to go up much more for the mold itself. Okay, so some of the different smoothing options. I'm going to go ahead and hit OK to my parting surface, and there's my first surface body. Okay, like I mentioned before, surface is very necessary. This is the surface that defines where the cavity and core will be split. Okay, and in my case, it's nice and flat, which makes it nice and easy. Okay, so notice now, in fact, let me edit that just real quickly here. Oh, I take that back. Notice now the tooling split button is available, and I wanted to get a message from the parting surface, but it is the shut off surfaces command that has that message that I was looking for. This is the message I was referring to. Now I could do a tooling split and the option is there, but I'm going to reach a problem, and the reason for that is I have not defined all the surfaces that will be shut off from the mold. Okay, and you'll see in this message here, the mold is not separable. Please select chains of edges to identify shut-off holes. Okay, so I need to go in and define where this mold needs to be shut off, where surfaces need to be defined to shut off the flow of whatever material I'm putting into the mold. Okay, so I'm going to go in and let's say, okay, I know any of these openings basically I have to define as shut-off surfaces. Now, easy technique is the same one I used earlier. Select tangency, automatically creates the loop. Okay, and bear with me for a moment. I'm going to go through and define some of these. So we have all of our defined shut-off surfaces. Tangency. Okay, and the moment I get the last one, this message turns green. Okay, and that's really what I'm looking for, because that means that I'll be successful in separating this into a core and cavity. Until I get this message, that other tooling split command would have failed. Okay, so this is definitely helpful feedback. Now that I've got all the loops inside of my parting line contained with shutoff surfaces, I can continue on with the tooling split command. Okay, so if I hit OK, you'll see it creates surface bodies and all those different surfaces, just plugging them up basically, nothing more. And now I can move on to the tooling split command. Okay, so I call up the tooling split and it asks me for a plane to start my sketch. Now, like I mentioned before, the parting surface defines the face that splits the core into the cavity, so that's just the plane that I'm going to select when I start my sketch. Okay, so I'll go ahead and bring that normal to, and we'll just call up a center rectangle and sketch it like so. Throw some dimensions on there, just because I don't want to leave anything underdefined. We'll leave that at 280, that's good. And once I exit the sketch, it'll automatically take me back into the tooling split command, and I'll get a preview of the tooling split. Okay, so see the yellow preview there. I can extend it. That looks to be far enough. Now I mentioned this interlock surface. This interlock surface option is important if my surface doesn't extend beyond the rectangle size, whatever size it may be, for your tooling split. So in other words, if I if I had a smaller surface than this rectangle, I would have to have this interlock surface option on. Okay, and that's just an important thing to keep in mind. If your tooling split is failing, you might just check this option and hit OK and see what result you get. Okay, because I know that my surface need to be bigger. You remember earlier I specifically set this surface wider so that I could create a tooling block that was smaller than it. So now I have a tooling block inside the surface. I should be okay without that. So I'll go ahead and hit OK, and it creates my tooling split. Okay, now I don't see much right now, but if I isolate any of these bodies, you can see the mold design. Okay, this is my mold. Exit to isolate. Let's go to the other one. There's the cavity and core. Okay, and if I go into the surface bodies, you'll see the different tooling split bodies, as well as the cavity and core surface bodies. And this is what it automatically creates in order to do that tooling split. Okay, so these are all the automated tools I was mentioning in the early presentation. Okay, now I can do the same thing I was doing earlier. I can export these into their own components if I needed to. If I needed to do additional work, or maybe I need to export these into their own components. That way I can assemble them as an assembly and then build whatever features I need to for the assembly of this particular mold. But the operation to subtract one body from another is done. Okay, so that is a quick intro into the automated tools that SOLIDWORKS provides for creating molds. Okay, so let's go ahead and move on. Okay, so the next thing I'd like to go over is an example of the not-so-automated tools that mold makers would use to create their molds when everything doesn't just fall together with a tooling split. I'd like to call up an example. Let's open it up here of the hook. Now, the reason I bring this up, first off, this is an imported model, which is a common practice for mold makers. A lot of times you get the models from other users, other softwares, and it's just a big dumb solid. And in this case, my parting plane and surface would be right down the middle of this hook, which is actually one solid face. Okay, and what was nice about the iPad is it had a clean face that I could click on and say, okay, that's my parting surface. And this one, it's not that simple. Okay, to show you what I mean, I can call up the regular parting line command like I did before and say, okay, I want to, first off, what's nice about the parting line command is I can actually split the faces, which helps me in this case. So if I check split faces, it'll actually split the faces depending on what direction of pull selection I use. So in my case, we'll say the right plane. I'll say, okay, I'll hit draft analysis. It'll automatically split the face along that plane and create a parting line. Okay, so for that it works great. You'll see there it collects all the edges, gives me a nice draft analysis, and I can hit OK. The problem ultimately I run into is when I go to try and create a parting surface. The parting surface is incomplete, it's not planar, so I run into issues when I go to do the tooling split and other things. Okay, so if I call up a parting surface command, you'll notice the issues I'm running into. Okay, and although it's small, you can see a bit of deflection in the parting surface, okay, which will cause a problem later on. So what I'm going to do is go ahead and bail on this method of creating the mold and use some of the other less automated tools, in particular Combine. Okay, so what I'm going to do is start a sketch on that right plane, bring it normal to, and I'm going to sketch a corner rectangle. Okay, now throw a few dimensions on there. So I just need, let's see, give me just a moment, a couple dimensions to get this fully defined. Lastly, a construction line to center things. Tie the two together, and I should have fully defined. There we go. Okay, so I have this fully defined sketch that represents the tooling block that I'm going to be using for my mold. Okay, so the next thing I have to do is actually extrude it. Okay, now here's the key thing. When I'm working with this technique, I want to be certain to use multi-bodied parts. Okay, I don't want to merge everything back together. Obviously, I don't want to merge anything back together because I would just obliterate the hook if I were to extrude right over it. Okay, so what I'm going to do is call up a regular extruded boss base. I'm going to extrude it mid-plane with a distance of 4 inches. Okay, that way it goes all the way across the hook. Now, the one thing I want to make sure I do here before I hit OK is uncheck merge result. Otherwise, that way I do actually end up with 2 separate solid bodies and not just one. Okay, by default, every extrusion you do, it merges with whatever is created from, and so you end up with one solid body. In this case, I want to avoid that, so I have 2 separate bodies, and so to do that, I just uncheck merge result. Once I have that, I hit OK, and my hook essentially disappears. Now it's still there, obviously. I just extruded over it. Now the next command I want to call up is the combine command. And definitely a very useful tool. Combine command is used pretty heavily by mold makers, but it's used in a lot of different practices in modeling. Okay, so what I'm going to do is go ahead and call this command up. It's under Insert, Features. See it right here, Combine command. Now you only see this if you have multiple bodies. If you don't have multiple bodies, then this will be grayed out like the cavity in the joint and some of the others. Okay, so it's all in context. Now to do a combine command, I just simply choose what is my main body and what body do I want to subtract from the main body. Okay, so in my case, my main body is obviously this tooling block. Okay, the body that I want to combine it with or subtract it with in my operation type, as it were, is the hook. Okay, so I'll choose the imported body 1, which is here. Then I can just hit OK. Okay, and while you don't see anything different on the outside, on the inside it has removed one body from another. In fact, if I do a quick section view, let's see if I can get it here. There we go. You can see if I section through half the model, I get a half of the tooling block. Okay, which is really ultimately what I'm shooting for. But right now, the way it is it sits as one block. Okay, I've taken one body, removed it from another, but I still only have one block as my mold. So I need to split that block into 2, core and cavity. Okay, to do that, I'm going to call up the regular split command. Okay, another very useful tool for mold makers. So if we go Insert, Features, you'll see it right here. It says Split. And what I'm going to do is split this part based on a plane. Okay, in my case, that same right plane that I started sketching on. Okay, so I'll click on the right plane and then it gets popped in as my trim tool, which defines where the block will be split. Then all I have to do is hit Cut Part. Okay, it automatically cuts the model and shows me the 2 resulting bodies in a list below. Okay, and you'll see it there, body 1, body 2. If I check both of these, you'll see I can go ahead and hit OK, and it'll split what was 1 solid body into 2. Okay, so there's my 2 separate bodies. And now, much like the iPad, I can right-click on an individual body, isolate it, and view it separately. Okay, so again, a common mold-making technique that doesn't really involve mold-specific tools. Okay, these combines and splits can be used by anyone. Even without this mold tools or insert mold menu up. Okay, so just some different techniques. Now what's neat about this is I can actually do this at the assembly level as well. Okay, so if I shut all this down, I'm going to go ahead and start a brand new part up. And I'm going to create a core and cavity block to start with. And they're both just going to happen to share the same size for time's sake. So let's see, 300 by 200, that's okay. And I want to extrude this out to a total depth of 75. Okay, so I'm going to save this as my mold bottom, we'll call it. Okay. Now the mold top is identical. So what I'm going to do is just do a save as and name it mold top. Okay, then I can hit save and now I have both mold top and mold bottom. Now to do this in assembly, obviously I have to make an assembly. So I'm going to go File, Make Assembly from Part. Okay, and insert my mold top to begin with. Okay, now what I need to do is insert the hook and position it just like I did when I was working in the part level. Okay, so it's going to take some mates and some moving things around. In just a moment, start to mate things up here. So I want the right plane here tied to this face. That's okay. And let's see, I want the top plane here. The right plane here. That's okay. And then, let's see, the last one should be, let's see. Okay. Let's go to the front plane here to the top plane here. There we go. Okay, so that should fully define the hook. There we go. And so now what I need to do is insert my other block. Okay, so I have the mold top, so that means I gotta insert mold bottom. And made it up as well. Okay, get that fully defined, everything's ready to go. So now I'm ready to do the cavity command. Now the cavity command, it has to be done in edit part mode. In other words, it's not an assembly feature. Okay, it's in edit component mode that I'll see the option. Now the way this works is you edit the component that you want to modify. So in my case, I want this mold top to be modified with the hook. So what I'm going to do is edit that part. So just right click, edit part. Oh, I gotta save it, excuse me. Let's go ahead and save the assembly first. And then it takes me into edit component mode. Okay, now all I have to do is go to insert features, and you'll see the option here for cavity. Now, I won't get this option if I'm in the part level. This is only assembly feature, but I do have to be in edit component mode to use it. So I'm going to call up the cavity command, and you'll see what's nice about the cavity command is I can actually scale right here in this command, which usually that's done at the part level. So if I'm importing a body, if I'm working with a body, and I'm trying to create a mold from it, a lot of times what I'll do is scale the model to account for shrinkage before I do any of the mold steps. What's nice about this cavity command is you can actually incorporate that scale right into the cavity command all in one shot. Okay, so it's not separate features and separate parts. It's all done right there in the one command. Okay, so now all I need to do is select my design component, which just so happens to be the hook. Okay, now I'm not going to scale it here because I scaled the hook earlier. I'm just going to go ahead and hit OK. And now the modification has been made to the mold top. I'm going to go ahead and get out of edit component for the mold top and edit the mold bottom. Do the same thing. So I'm going to go to edit part mode. I'm going to again call up the cavity command. Again, use the same design component, the hook, and then just hit OK. Okay, and now I've actually modified both mold top and mold bottom, although we can't see it yet. So I'll get out of edit component mode, and now I can do just like I did with the iPad. I can right click and isolate these components. Okay, so there's one half. Get out of the isolate, isolate the other half. Okay, so essentially the same thing we did before in the part level, just done in the assembly. Okay, a lot of different reasons why I would want to do it with the assembly, but definitely a very useful tool. Okay, so let's go ahead and move on. So the next thing I'd like to go over is creating a mold from scratch. And not just creating the mold, but also creating mold-related features and then dragging it into an assembly to show some of those features off as well. So the part I have is this particular bezel, and I've already done some of the draft features and so on to get this thing ready, but I haven't done any of the mold-specific features. So that's where I'm going to start. I'm going to start with my parting line command, and I'm just going to go with a default parting line. That looks to be good. The draft is good. So I call up the parting surfaces command. I'm just going to take a look at the different types of parting surfaces I can get, because that's not really what I'm looking for. Neither is that. That's close, but it's still not it. So I'm not going to use a parting surface command. I'm going to create this surface manually for the parting surface for the tooling split. To do that, I need to convert one of these faces to a surface body. So what I'm going to do is just highlight this face and hit knit surface. Okay? And what that'll do is convert that to a surface body. See there? That's the surface body. Okay? What's so neat about that is now I can extend it with an untrimmed surface command by 15%. That looks good. And now I have a surface I can use as my parting surface. Now I'm still going to trim this one more time before I actually use it for the tooling split, but that's going to be the surface I use. So the next step is to go through and create two sketches. The first sketch is going to be just the size of my tooling split, the size of the tooling block I'm going to use. Okay. The second sketch is going to be the sketch that trims the parting surface. Okay, so this sketch is done. I'll go ahead and exit that. I'll start another one on the front plane. Okay, and I'll go ahead and exit that sketch as well. So, like I mentioned before, I'm going to use this sketch to trim this surface. And to do that, I'm going to call up the Trim Surface tool. Okay, so I call up Trim Surface, make sure Sketch 2 is selected as my trim tool, and just come over and hover over and click on the surface body I want to keep, which is this inside one. Okay, once I do that, go ahead and hit OK. Now I have a complete parting surface. Okay. The last step I have to do before I do the tooling split is the shutoff surfaces. Okay? And because it's inside of the parting line, SOLIDWORKS automatically finds the openings and creates the shutoff surface loops. So all I need to do to this one is change the loop style from contact to tangent, and then change the tangent orientation. And once I do that, I hit OK, and it creates my shutoff surfaces. Here we go. So the next step is the tooling split. Now when I click tooling split, it's asking me to choose either a place or a plane or a face to start a sketch on, or choose an existing sketch. I already have an existing sketch, so I'm just going to click on that one, and it gets selected for the tooling split. Now the one important thing with this tooling split is I need to make sure I have interlock surface checked. That's because my parting plane, my parting surface, is not bigger than the tooling split. Okay, so I need to make sure that option is on. Now let's go ahead and hit OK. Okay, and it creates my cavity and core. I'll go ahead and isolate one of them. You can take a look. So the next thing I'm going to do is add a library feature, and what I've done is I've created a sprue, runner, and gate all in a single library feature. Okay, and what I'm going to do is just drag this feature out onto the part. Okay, just like typical library features, it prompts me for selection, so I'm going to say, okay, I want the origin and the top plane. Okay, and it locates it. Okay, now I've saved this as a library feature because this is something you'll do over and over again, so it makes sense to make it a library feature. And to show you a quick section view of what we've done, that's it. Right here. Okay. So the next thing I like to do is, if I isolate this lower body, I want to take care of the core features that are necessary for these undercuts. Okay. So what I'm going to do is start a sketch on the side core sketch plane. And let's make this hidden lines visible so I can see what's going on. And I'm just going to convert some of these edges over and start sketching. Okay, the last thing I'm going to do is mirror this over to the other side to account for that other undercut. Good. And now I can call up the core command. Now the core command is on the Mold Tools toolbar. You'll see it right here. Okay, and all I have to do is define the width. 10 and 10 is fine. I'll select that body, and I'll just go ahead and hit OK. And there are my first two core features. Okay, now I'm going to do that once more with the lifter. So I'm going to start a new sketch on this lifter sketch plane. Normal to the other side, and again hidden lines visible. I'm going to start by converting entities. So I'll do convert entities, okay, and then make this lifter much bigger. Okay, so I've got a fully defined sketch. Again, I'm going to exit and go to the core command. And this time I want a, let's see, 5x5. Okay, select the body again. Then I just hit OK. Okay, so there's my second core. Now the next thing I want to do is I want to insert ejector hole pins for these pins. They're going to be ejecting the mold out. Okay. To do that, I'm going to start on the back side. Let's go back to shaded with edges here. I'm going to start a sketch on the back side, and I'm just going to sketch a circle like so, with a diameter of 4. It happens to be 24 from the edge, and we'll make it horizontal so we fully define it. Okay, great. So now what I'm going to do is an extruded cut through all. So it goes through the whole body. I want to make sure I have specific bodies selected, in particular this one. Okay, I only want this to affect one body. Okay, so I choose that one, I hit OK, and I have my cut. Okay, now the next thing I want to do is go in and pattern this cut. So I'm going to go ahead and create a pattern. Okay. Or excuse me, I'm going to go ahead and start a sketch to create that pattern. So I'm going to go ahead and start a sketch. I'm just going to put, let's see, a few random points here. Let's see, so point here, 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 here. And I'm just placing these random. I'm not too concerned about their exact location because I'm going to let fully defined sketch handle it. So what I'm going to do now is just leave these floating. Actually, I'm going to do just fully defined sketch and let that add the dimensions in, just for time's sake. So I've got all those points located. Now what I'm going to do is a sketch-driven pattern. Okay, so I select that sketch as the sketch to drive it, and then I want to choose the cut extrude command as the feature, and I just hit OK. Okay, and now let's see, when I go in and isolate the bodies, let's take a look here. You'll see my features are associated with it. Now it looks like I made a mistake, and I need to edit this body, edit this one, and I need to change the body that it's affecting. So clear selection, so I'm going to choose this one, and hit OK. There we go. So now if I isolate this one, that's looking correct. Okay. So I selected the correct body. Now I have all the ejector pin holes and all the necessary features. There's one last thing I want to do before I move on to the assembly, and that's export each one of these bodies as an individual component. Okay, and there's a tool specifically for that called Save Bodies. So I'm going to go ahead and call that up. So if I go Insert Features, you'll see it right here, Save Bodies. And what I'm going to do is just export each one of these bodies as an individual component. And what's nice about this command is you can actually build an assembly right here in this command. Okay, you'll see the option Auto Assign Names. I'm going to go ahead and hit it. It gives the names per body. What's nice about this, what's cool about this is I can actually build an assembly right here. Okay, so mold insert. Okay, go ahead and hit save, and then just hit OK to the command, and it builds an assembly out of what is now a part. Give it a moment to update, but then it minimizes it. I'll minimize this, and it takes me right into my assembly, which is now multiple components, which was individual bodies before. Okay, so definitely pretty helpful in this scenario where I want to export this out as individual parts now that I can work on it at the assembly level. Okay, so while we're there, let's go ahead and move on to the assembly. Okay, so I'm going to go ahead and call up the assembly. And I've done a lot of the work just in interest of time to get some of this stuff done so I can explain a bit of it. And what I essentially did was insert that mold insert that I just created in the last step, inserted the assembly into this mold base. Okay, by the way, this is something I downloaded from 3D Content Central. You can get it as well, just a standard mold base. And so I inserted this mold into it. Okay, and then I also did a mirror components to mirror a left-hand version to the other side. Okay, so I have a left and right-hand version created in the particular assembly. Now, I've also broken some of the relationships and added a few so that I get actuation out of these lifters. So if I grab this and pull on it, you can see the lifters begin to rise up and down. Okay, grab it again. You see the components going up and down. Okay, so everything appears to be working except for this ejector pin. And what I want to do is edit this ejector pin because A, it's too long, and B, there's only one of them and there's ejector pin holes everywhere, so I obviously need to add a lot more. So what I'm going to do is go ahead and open this part up, and what I want to do is do a sketch-driven pattern of it using this sketch right here, sketch 9 bezel. Okay, bodies to pattern. I'm going to select that body and hit OK. Okay, so that takes care of one mold. Now, still doesn't take care of the height. These ejector pins are way too long. And so the next step for me is to do what we call a cut with surface command. Okay, on the surfaces toolbar, see it right here, it says cut with surface. And what this allows me to do is use a surface and cut components with it. Okay, so what I'm going to do is say, okay, I want to cut with this surface. And I want to flip that direction up, and I want all bodies. Okay, and it's going to cut anything above that surface. There we go. Okay, so now the ejector pins fit the contour of the mold. So the last step for me to do is I want to mirror these to the other side so I take care of the other mold as well. Okay, so I'm going to bodies to mirror and start highlighting bodies. And hit OK, and we have our mirrored ejector pin set. Okay, I'll save this and go back to the assembly. And let it update. Now the next step I want to do is add some water cooling features to the top half, the fixed half of this mold base. Okay. Okay, so now I go back here. I've got this in place. I'm going to go ahead and show you. You see all the ejector pins now, and notice that when I get to the bottom, they're flush with the mold, which is what I'm shooting for. Okay, so all the ejector pins in place are working now. So the next step, like I said, is I want to do some work to the fixed half to add some water cooling features. So what I'm going to do is just activate the fixed half only display state, so I can work on that. And if I open this top half up, you'll notice I have a 3D sketch associated with it. Okay, this 3D sketch is what's going to define my holes for the water injection to keep it cool. Okay, so I'm going to add a few different types of holes, and I'm going to go to my design library to do it, this waterline feature. Okay, I can select the waterline feature, drag it out, say I only want a hole for these, and I want it to be so deep. Okay, do that again. Okay, I'm going to do the same thing here except with plugs. I want to plug these sides. So I want to plug so deep. Okay, and I also want another one. Plug that deep. Okay, and then lastly, I'm going to add a few connectors to the front. There's the depth, and another one. And I just hit OK. And there are my waterline features. Okay. So it's just a simple matter of adding them to the library features, and then dragging and dropping them onto my different mold assemblies. And let the assembly update, and there's our holes. You'll see the waterline holes here. Okay. So again, not much different than in-context assembly modeling, just some specific features for mold makers. Okay. I'd like to thank you for joining us. That just about does it for this particular webcast. Thank you for your time.